So good morning, my colleagues, and I do hope everyone is well this morning. I want to pick up where we left off. We left off right here discussing the relationship between nominal rates, which we now know what that means, and the real rate, which we now know, okay? So the nominal rate, which is right here, and you can see they define that right there, right, is equal to the real rate. And in the history, they use a star, and I don't know why they use a star, but it's always been with a star, okay? And and then I is the expected inflation rate. So you can see if this was 0 here, basically the real rate would be the nominal rate. And you could approximate this equation here by simply saying that the real rate is the nominal rate minus inflation, okay? So those are important definitions there. So equation 6.1 shows that 1 plus the nominal interest rate equals the product of 1 plus the real rate and 1 plus the expected inflation rate. So, and again, they say it right here in words, what you see right here. The real rate is approximately equal to the difference between the nominal rate and the expected inflation rate. So as things, and there's an important little point here, okay? In market environments with high interest and inflation rates, however, the approximation in equation 6.1 becomes less accurate. So it's just an approximation, all right? All right. So there's a nice example here of this gentleman, and he's, I don't know, he's a survivalist, whatever, and they show that the inflation is very high in this example, 9%. And basically, he has an investment that's going to pay 21%, which is quite good, right? So you can see the real rate on his investment is 12%. You just subtract off the inflation rate from the nominal rate here. So on the basis, so again, this is approximate, right? Bert might expect that if he invests 100, he could buy 112 cans of Spam next year rather than 100 cans, a 12% increase in purchasing power. Suppose that Bert invests the money, earns a 21% rate of return, and 1 year later has $121. By that time, 1 can of Spam costs $1.09, so Bert is just barely able to purchase 111 cans, right? Bert's purchasing power has increased by 11%, not by the 12% that he expected. Equation 6.1 reveals that the exact real return on Bert's investment is 11%. So you can see here, if you do it exactly versus approximately, you notice the approximation symbol here, right? We got an approximation symbol there. And here's the exact equation right here. So that's an important thing, but it's close. All right, so let's catch this little piece here, and I hope it comes through on the microphone. Let's give it a shot.
When people and firms invest money, they have to think about the effect that inflation will have on the purchasing power of money over time. Generally, investors seek returns that are above the rate of inflation. For Bert Gummer, only an investment that pays him a return above the realized inflation rate will allow him to purchase more Spam in the future than he can buy today. After all, part of the incentive to save and invest is to increase consumption in future years. In Bert's case, if he has $100 today and Spam costs $1 per can, then he could purchase 100 cans right now. However, Bert's wife Heather suggested he might be better off if he saves the $100 and invests it. If inflation for the coming year is expected to be 9%, then SPAM is expected to cost $1.09 1 year from now. If Bert can earn a nominal return of 21%, then Heather reasons that he will be able to buy more SPAM in the future than he can now. Given the expected inflation of 9%, Bert figures that his real return or change in purchasing power will be about 12%. If this proves to be the case, he will be able to buy 112 cans of SPAM in a year, 12% more than he can buy today. If Bert earns the 21% nominal return, then after 1 year he has $121, and if the can of SPAM costs $1.09, then he can buy 111 cans of SPAM. This is less than the approximately 112 cans of SPAM that Bert anticipated being able to buy. Since Bert can only buy 11 additional cans of SPAM and not the 12 cans he estimated, his actual change in purchasing power is 11%. This is found by dividing 111 cans of SPAM by 100 cans of SPAM and subtracting 1. Equation 6.1 can be used to find the exact real rate of return. The equation shows that 1 plus the nominal interest rate equals the product of 1 plus the real interest rate and 1 plus the expected inflation rate. Doing the math, we find that the real return is 11%.
All right, so that just reiterated kind of what I said, okay? So what I want to get back to here is other things affect the nominal rate too, right, that you're going to pay. And it's not only are they affected by inflation, but also by risk, okay? So if you buy bonds and they're junk bonds, which means the company's very close to default, you're going to ask for a greater return. So you can see right here what I'm driving at, right? Investors will demand a higher nominal rate of return on risky investments. So the additional return that investors require as compensation for bearing risk is called the risk premium. Okay, so these are important terms. All right, so what I want to define here is a term called the risk-free rate of return. All right, so the risk-free rate of return is shown right here, okay? So the risk-free rate of return is affected by inflation, as you can see, and the real rate, okay? So it's not affected by risk, but it is affected by investors' inflation expectations, okay, the one we went through. So here is, you can see that the risk-free rate of return is, definitely got a component that is determined by inflation and the real rate over here, okay? So if you look here, if we go back a little bit, R, if we make R star plus I, that gives us that, another term for the rate is the risk-free rate. Okay. So, as you know, inflation is going to change over time, and inflation's your worst enemy. All right, now how do you what is the what determines the risk-free rate? And you can see here, securities are as close as we can get to the real world to a risk-free investment is Treasury bills. Okay, so they use Treasury bills for the risk-free rate. So it's important to make that comparison right here. Everyone see that? Treasury bills. Okay. So you can find nominal rates of return on T-bills on the web and many places. Okay. So that's important to know. And I believe there's a graph here. So here is the Treasury bill rate, and here's the inflation rate. And it's important to understand how they kind of track each other somewhat closely, all right? It's a good graph, and it goes from 61 to 2016 here. All right, and you can kind of see that that the annual rate was basically this is the Treasury bill rate here, and here's the inflation rate. So you can see it went negative. Anything that's colored in orange is a negative real interest rate. But you can see how they move in a similar fashion, and they state that, and that's stated right here, right? It's stated right here. They move in a very similar fashion, and it's clear. All right, so now we get back to this. So here's the risk-free rate, which we know how to define. Now we're going to add a risk premium because we bought something that's risky and it could default. So we add that component to that. And basically, we don't know the size of the risk premium, but it could depend on many things. Is the company in good shape? And you can see they use the word junk bond here. You should study and learn that word junk bond or high yield bonds because it's an important word. It basically means a company's issuing bonds because they're in trouble, okay, of default. All right. And so now we want to look at the yield curve a little bit. Here's the different yield curves for treasuries. You'll notice it says Treasury yield curves here. And here's the Treasury yield curves. And normally, the longer you go out, the higher the risk. So they'll be increasing over time. You notice over time, it's maturity over, against time. So you'll notice how this is going up, and then here it is going up. But there were times when it was pretty much flat because of conditions in the economy, all right? And you can see they talk about a flat yield curve. It's a yield curve that indicates that interest rates do not vary much at different maturities, okay? So it's important to know that, okay? And there's a couple of things here about inflation-linked bonds, right? They have inflation-linked bonds you can buy that will go up in value with inflation. The interest rate will rise, and they talk about that here as the interest rate is rising with inflation. All right, so here's the yield curve. Again, here is the year, and here's the 5-year Treasury bond yield. 1-year Treasury bill minus the 1-year Treasury bill yield. And these gray bars indicate what? They indicate recessions. And you could basically see that during recessions, the yield curve is inverting, right? You can see the yield curve inverting. So you can see the business cycle and the yields are directly related to each other. This is a really important graph. And basically they talk about the 10-year Treasury note yield on 2016 reaching an all-time low. I believe it's actually low, much lower now. And you can find that out by listening to Bloomberg every morning like I do. I think it's around maybe 1%. So, if not lower. All right. So I'm going to go past these these theories because they're really just theories. All right. So what I'll do is we're about 15 minutes into this now. So I'll pick up at risk premiums. Okay. All right, everybody. Talk to you later.